In this video, what we are going to say is about the introduction to data structures. So, what is data structure? A data structure is a way of organizing, storing, and retrieving the data and perform operations on these data in an efficient way. In an efficient way. So, what do you mean by this? So, what is data? So data may be anything. It may be from integer, floating point up to a record. That is considered a student record. A student record may consist of different details. For example, personal details, academic records, and then displacement details also. If you take personal details, it may consist of a roll number, which may be a text field, then age, which may be an integer, date of birth, which is a date field, and so on. And if you take academic record, then his internal marks, end semester exam marks, then the credits which he has earned in all the semesters, all those things. If you take placement, in which company he has placed, what is his salary, all those things, how many offers he has. So all these things has to be recorded in a college environment. Likewise, if you take employee details, what is his personal details alone, then what is his salary details, what is his savings, income tax details, all those things. So whatever it is, how we are going to store these data, in what structure, so that is what more important, and how we are going to organize this data. So for example, we may want to store all these things in a database. Then which database we are going to adopt? Whether it is an Excel sheet or an Oracle or a SQL server or something else. So how we are going to store these data? And then the stored data, we have to extract information. So for example, in my class, how many students got above 90%? This I would like to know. So likewise, so how you are going to extract data from this? A particular data according to the uh, people who ask for that. So how we are going to extract data and how we are going to perform operation, whether updation, insertion, the insertion of a new data, deletion of an existing ones. The student has passed from 12th to higher education. You can archive that data. So how what we are going to do on those data in an efficient way. So that is what. So for that, how we are what structure we are going to adopt in order to store these type of data. So each data structure has its way of application. For example, a single dimensional array. A single dimensional array, it can be used to store homogeneous type of data. What do you mean by homogeneous? Data of the same type. If you are going to declare an array of integer means all the data in that will be integer. If you are going to declare a floating point array, all the values in that will be floating point. So likewise, so specialized data structures can be used to solve complex search algorithms like hash table, etc. So these things will be discussing soon. In general, data types, they broadly they can be divided into two: primitive data types and composite data types. What is primitive data types? Composite data types, and then abstract data types. Abstract data types are nothing but functions which we are going to write, but without giving any implementation. That we will be seeing shortly. The first we will see what is primitive and composite. Primitive data type. These are basic data type that directly operate upon machine instructions. So they can be directly stored in the memory locations as an individual, as an atom. So here some of the primitive data types are integers, floating point. Integers are nothing but a whole number without any decimal point. Floating point are the numbers with a decimal point. Boolean, either a 1 or a 0 or true or false value. Then character, single character. Then constants. Constants are nothing but the values. It may be a string constant, it may be an integer constant, it may be a floating point constant, whose values remain the same once declared the start of the program, the values will remain the same throughout the program. You will not be able to change the constant value. Then strings. Strings are nothing but a combination of character. Whereas a character is only a single character. A string is nothing but, for example, if you say welcome, welcome consists of the following characters: W, E, L, C, O, M, E. So totally 7 characters. All these things together form strings. Likewise, a strings consist of a group of characters. Pointers. Pointers are nothing but they directly point to the memory location. So the data which is stored in the memory locations can be directly manipulated. So that is what for pointers. Composite data types. What do you mean by composite data types? These are derived from the primary data types. So based on the primary data type, what we have declared, what we have seen in the previous slide, based on that, you build more structure. They are said to be composite data types. Say for example, which you have already known from your previous semester, you have studied C++. In that you should have studied this array structure. So array is, if you have declared x of, so if you say x of 5 means, uh, 5 which is of type integer means all the values from x0 to x5 will consist of integer. So when you say integer, which is nothing but the primary data type. So based on the primary data type, this array has been built. A group of an array of integer, an array of floating point, an array of string, likewise we call. So these are derived from primary data type. List is also similar. You can build a list using a pointer, which we have seen the previous as a primary composite data type, or primary data type, or you can form using the array. Okay. Then stack, queues, linked list, trees, graphs, all these data structures we are going to see in the next coming videos. But in this, what we have, what is these are all also composite data types which are built from the primary data type. Abstract data type. What is an abstract data type? An abstract data type is defined in terms of its data items and its related operations rather than by its implementation. In this, only what operations are to be done is mentioned, but not how. So you will be given the function and what it will do. That's all. No implementation, no coding, nothing is given. So why it will be given to the so the developer has to, by seeing that, he can develop his own code under the given function. So a data structure is given, and what are all the operations that can be done on that particular data structures. The function's name will be given without what it has to do, that information also will be given, but how it will be done, the actual technique will not be given. It is up to the developer to use a data structure of his own choice and develop the operations mentioned. So the implementation is left to the developer, as it gives an implementation independent view only. It is called as abstract. So in another way, an entity can be considered as a black box where users can only see the syntax and semantics of its operations. The representation of the data structure is hidden. So it does not specify how data will be organized in memory, how it is stored in memory, what way it is stored in memory. All those things is not defined. And what algorithms will be used for implementing those operations will not be given. Basic ADT operations. Some of the basic ADT operations are constructor or destructor, where you creates or deletes a new instance of an ADT object, and then transformer. It changes the state of one or more of the data values of an instance. What do you mean by that? For example, we create an instance. We may want to do some modifications on that. That can be done using this transformer. Observer, it doesn't do any modifications, but it just print a value. So whatever is there, that will be observed. So it is called observer. Then iterator. It allows us to process all the components in a data structure sequentially, which means if I am going to print the values which are stored in a linked list, then I will be going for a iterator. What is an iterator? It may be depending upon the particular language. It is a for loop or a do loop or a while loop. And then in an iteration, we will process. So, for example, I want to print all the values in a particular uh, set of objects. Then iterate, then extract one by one instance and see what is stored in that. So, how you can do that is through iterator only.